Intuitive ideas of differentiable functions. A differentiable function is a function whose derivative exists at each point. Mathematically, a function f is said to be differentiable at a point, suppose x equal to a, if its derivative, that is f dash a, exists. We generally define the derivative at a point in terms of limit as limit f of a plus h minus fa divided by h approaches to 0. And here h is the increment, small increment in a, which is called suppose h. If the derivative exists, then we say the function f is said to be differentiable at a point x equal to a. Remember, a continuous function is not necessarily a differentiable, but a differentiable function is necessarily continuous at every point where it is differentiable. In the previous video, we have discussed about continuous function. So, a continuous function may or may not be differentiable, but a differentiable function will be continuous at every point where it is differentiable. For example, the absolute value of a function. Suppose the absolute value of a function y equal to modulus of x or absolute value of x, and this function is continuous but not differentiable at x equal to 0. At x equal to 0, the function is continuous, but at x equal to 0, the function y is equal to mod x is not differentiable. This is the geometrical representation of the function y is equal to modulus of x, or you may say the graph of y is equal to modulus of x. And this function is, you see, this function is continuous at x equal to 0, but the function is not differentiable at x equal to 0. You cannot take the derivative of the function y equal to x at x equal to 0. If you find the derivative that is in terms of limit, as I have told you, limit of f dash a in terms of f dash a equal to limit of a plus h minus fa divided by h approaches to 0. If you take the function y equal to modulus of x in this form, you cannot find out the derivative of the function y equal to modulus of x will not exist. So this point you should remember, a continuous function is not necessarily a differentiable function, but a differentiable function is necessarily a continuous function at every point where it is differentiable. Other examples of continuous function which are not differentiable, they are the function with a bend, so a vertical tangent. These functions are maybe continuous but not differentiable. Now let us discuss what is continuously differentiable. When you say function is continuously differentiable, a function f is said to be continuously differentiable if the derivative exists and is itself a continuous function, that is, the derivative is a continuous function. Okay, if the derivative exists and the derivative will be a continuous function, then you say that it is continuously differentiable. So when you say derivative is a continuous function, before going to know about the derivative when it is a continuous function, we should have idea about the first derivative, second derivative, like this. Suppose we denote the continuous function are class C0 function. C0 functions are the continuous function. So what will be the continuously differentiable functions? How you can represent continuously differentiable functions? Continuously differentiable functions, they are basically represented by class C1. This is called first derivative. Class C2, this is called the second derivative. Likewise, you can define class Ck, which is the k derivative. So a function is said to be continuously differentiable if the first k derivatives, that is f dash x, f double dash x, up to fkx, all exist and are continuous. For example, suppose the function fx that is equal to x square sine 1 by x if x not equal to 0, and the function fx is equal to 0 if x equal to 0, and this function is differentiable at x equal to 0 but not continuously differentiable. You find out the derivative of this function when x equal to 0, but you cannot find out the derivative of this function fx when x is not equal to 0. Let us verify it. So the first derivative of the function fx, that is f dash x, is equal to limit of x plus, this is x square. So if you take the increment in x, it will be equal to x plus h whole square. Here also in sine function, the increment in x will be sine 1 by x plus h minus x square into sine 1 by x. You put the same formula that we have discussed to find out the first derivative, limit fa plus h minus fa divided by h approaches to 0. I have used this formula. So what will be the value? The value of this first derivative will be equal to 0. If the first derivative exists, that is f dash x exists when x equal to 0, we have verified it. Therefore, the function is differentiable at x equal to 0. But will it be differentiable when x is not equal to 0? Let us verify it. If you find out the first derivative of x, then this will be equal to, if you put the formula derivative of product function, then derivative of first function, that is x square, it is equal to 2x into the second function, that is sine of 1 by x, minus derivative of the second function, that will be equal to cos of 1 by x into 1 by x square, and when it is multiplied with x square, then that will be equal to 1. The second term will be equal to cos 1 by x. So which has no limit as x approaches to 0. When x approaches to 0, there is no limit for, you cannot find out the limit of the first derivative of the function. So the function fx is differentiable but not continuously differentiable, because you see, you can find out the derivative of the function at x equal to 0, but further if you find out the derivative when x not equal to 0, you cannot get the derivative, you are not getting the derivative. So the function is, you can find out the derivative of the function, that is the function is differentiable but it is not continuously differentiable. In mathematical physics, we will encounter with these two things, that is continuous function and differentiable function. So you should have idea about what is continuous function and what is differentiable functions, or intuitive ideas of differentiable function and continuous function. These two videos are very useful to learn mathematical physics. Thank you.